everyone. So we are on Unit 6, Day 3. So this is page 15 in your packets, and we are looking at using graphs to solve equations. So it says the emphasis of our current unit of studying is on graphing. In this lesson, we will use a graphic approach to solving equations. The solutions of the equation f of x equals g of x, so when I have two equations equal to each other, variables on both sides, the solutions are the x values, or the x coordinate, of the intersections of the two graphs. So if I were to graph one half of the equation, everything to the left of the equal sign, and also graph the right side. And it's the x coordinate because we are looking for the input that gives us equal output, gives us the same output. So looking at this graph here, this would be our solution, because it gives us the same output, the same y value. Remember, x is your input, y is your output. So then below, let me adjust my screen. It says if the graphs do not intersect, there is no solution. So that would be something like two parallel lines. They're never going to intersect, so they'll never have the same output at the same time, so there's no solution. If the graphs share every point in common, so two of the exact same lines, two of the exact same equations, there are an infinite number of solutions. So that would be something, the most simple example being x equals x. No matter what number you put into that, because they're the same line, they're the same equation, no matter what number you put in, that would be true. So there's an infinite number of possible solutions. So it says use the graph to solve each equation below. So for number 1, we have this graph here, and we have the intersection point 1, -3. So this is where the two lines intersect. So we could actually pretty easily solve this algebraically, which I'll show you after. But remember, the solution on a graph is our x coordinate. So that means for this question, our solution is x equals 1. So when we solve this, we should get x equals 1. So if I wanted to do this algebraically, I would add 4x to both sides to get my x's together. So I have now 5x's, add your like terms, minus 4 equals 1, and then I would add 4, and I get 5x equals 5. So then I would divide both sides by 5 and get x equals 1. And notice on the graph, that was my x coordinate. So this can be really helpful when you are checking your work, or if you are doing a multiple choice question and you don't have to solve it algebraically. This is a really great tool to use. Question 2. Here's our intersection point, which is 1, 2, 3, 4, 2. So that means for both of the equations, x minus 2 and 2x minus 6, if I plug in the x value 4, I get the y value 2. So my solution is x equals 4. And a way to remember that you need the x coordinate is that, well, our equations had x's in them, so our solution should also have x equals. For number 3, here's our point of intersection. This is the point 3, 2. So our solution would be x equals 3. All right, pause it if you need to. On the bottom here, it says the accompanying graph shows the function y equals x squared plus 4x plus 3. So that's this quadratic that's graphed here. Use this graph to help you solve each of the following equations. So I have x squared plus 4x plus 3 is equal to x plus 3. Now this isn't something we know how to solve yet. You'll learn how to solve this later in the year. but we can do this graphically. So I already have this graphed. That is the quadratic that they gave us. So now what I'm going to do is I'm going to graph x plus 3. And you can get this in your calculator if you just type in y equals x plus 3 and then look at the table. Or the y-intercept is 3, the slope is 1, and you could graph it that way as well. So I'm going to go ahead and graph these points now. So I have 0, 3, 1, 4, let's see, I gotta go the other way. -1, 2. And it looks like my line is following this pattern because the slope is +1. So looking at my intersection points here, I have the point 0, 3. And I also have the intersection point here, -3, 0. Now, our equations were x squared plus 4x plus 3 and x plus 3. So that means the x coordinate is what we're looking for. So my solutions are x equals 0 and x equals -3. We only want the x coordinates. So I'm going to do the same thing for number 5. It's already graphed. X squared plus 4x plus 3. And then I'm going to graph -x minus 1. So again, you could put this in your table, but I know that negative y equals -x minus 1 starts at -1 on our graph. And then from there, the slope is -1, so I'm going down 1 to the right 1, down 1 to the right 1. But you could get this from the table as well. Then I'll connect. I missed that last one, but that's okay. So again, we are looking for where we intersect the graph, and that's at the point -1, 0, and -4, 3. So then my solutions are x equals -1 and x equals -4. Those are the x values that give us the same output. Now they didn't ask us where the two lines are equal to one another, x plus 3 equals -x minus 1. They did not ask us that, but we can see here that they intersect at the point -2, 1. So that means my solution, if I were to solve this, would be x equals -2. But again, that's an equation that you can solve pretty easily. All right, I'm going to move on to the next page. Oh, it got stuck at the end. Okay, so this is the next page of your notes. So it says, for some graphs, it may be necessary to estimate the solutions because of the points of intersection may not be integer coordinates, like if you get a decimal. To increase the accuracy of our estimates, we can use the intersection feature of our graphing calculator. An example of this is shown below. So we have the equation we're trying to solve, 2x minus 4 equals x squared minus 4x plus 1. And we took each side of those equations and plugged them into y1 and y2. So it looks like they took this half and plugged that into y1, and the second half and plugged it into y2. So in order to do that, you would click y equals on your calculator, clear out anything that's there, and I would type 2x minus 4. 2x minus 4. Oh, that didn't make an x. For y1, and then in y2, I would put x squared minus 4x plus 1. So I have one half of my equation in y1 and the other half in y2. I forgot to arrow out. So x squared minus 4x plus 1. So then if I look at the graph, it should look similar to what they have. Yep. So then it says press second trace, which has the little word calc above it, and choose intersect choice 5. So I'll show you where that is on the calculator. Your second button, that's the blue button. And then trace is this button here next to graph. So it says calc above, and it'll calculate the intersection for us. So I'm going to hit second trace, and then you're going to choose choice 5 intersection. And then it's going to ask you to estimate. So I'm going to get close to one of the intersection points, hit enter, get close to the second intersection point, hit enter, and then hit enter again. You have to hit enter 3 times, and then it gives you the intersection point is 5, 6 for this one. So that tells me that the solution is 5, 6, and then I can do it again. So I'm going to hit second trace again, choice 5. This time I'm going to go over here. I think you should put both of them. Yes, okay. So you're going to put both of your little tracer things on the one you're looking for. So if I'm looking for this intersection here, I'm going to put both tracers there. And I get the point 1, -2. So one solution is x equals 1. And then again, to get the other one, I'm going to hit second trace, choice 5. I'm going to arrow over to my other intersection point, just about. Hit enter, enter, enter 3 times, and I get the point 5, 6. So that means my other solution is x equals 5. Those are the two x values where they have the same output. So for 6 and 7, we are going to do these in our calculator. Question 6, we have negative 5x plus 2 equals 4x minus 7. So I'm going to put this into y1 and this half into y2. It does not matter which one you put into y1 and y2. I just typically put the one on the left first. So I'm going to clear out what I have here. So for y1, I'm putting negative 5x. Make sure you type the negative and not the minus. Then plus 2. For the second y2, I'm going to put 4x minus 7. And then I'm going to look at the graph. I've got 2 lines intersecting. I'm going to hit second calc, choice 5. And then hit enter a bunch of times, and I get the intersection point 1, 3. So that means my solution is x equals 1, because they intersect at the point 1, -3. Number 7, I'm going to do the same thing. Put the left into y1 and the right into y2. So I'm going to go to y equals, clear out what's there. Then I will put in 3x minus 7. And then the square root, which is right here on the x squared button, but it's blue, so I have to hit second, then x squared, x plus 2. So there's my two equations. If you ever hit graph and your graph looks really weird, like really zoomed in, really zoomed out, something like that, if you hit this zoom button and you choose choice 6 zoom standard, it brings it back to the regular graphing screen, just like this. Just if yours looks weird, that's what's going on. You can also always reset your calculator by clicking second plus 712, and that'll do the same thing. So I'm going to find the intersection here. So I'm going to hit second calc, choice 5. Enter, enter, enter. So this time, what's it say? Round to the nearest hundredth. 100 has 2 decimals, or 2 zeros, so I'm using 2 decimals. And my x value is 3.08. So at about 3.08, they have the same output. Okay. One more example here. Not only can we use the graph of functions to solve equations, we can also use solve equations when the functions are represented in tables. So we are going to look through the tables, which you can hit table right here, the same as graph, but it's in blue, so you have to hit second first, second table, and you can see all of these x values and the y values. And remember, the solution is the input where the output is the same. We're looking for where the y value is the same. So you would just look through the table and see where the output is the same. For this last one we did, it was at a decimal, 3.08, so that's why you don't see it here. But if it's a whole number, you will be able to see it here. So let's go ahead and do this example. We are going to look at the equation negative x squared equals x minus 2. So I'm going to put negative x squared in for y1 and x minus 2 in for y2. So I'm going to clear out what's here. And I have negative x squared. Make sure you hit the negative and not the plus, or not the minus. So negative x squared. And then my other equation, x minus 2. This time I got to hit the minus, not the negative. So I'm going to look at the tables. And I'm looking for the x values where the y values are the same. Looks like I found one right here at x equals negative 2. And there's another one at x equals 1. So I'm going to copy this section of the table down into my table on my paper. So I have negative 3, negative for my x value, and I put y equals negative x squared in y1, and then y equals x minus 2 in for y2. So for y1, I have, when x is negative 3, I have negative 9 and negative 5. I have negative 2, negative 4, negative 4. Then I have negative 1, negative 1, and negative 3, 0, 0, negative 2, 1, negative 1, negative 1, 2, negative 4 is 0, and 3, negative 9, 1. So all I did was just copy those values into my table. All right, so I know that my solutions are where the outputs are the same. So I see here that I have negative 4 for both of my outputs when x is negative 2. And down below, I have this solution here. Both of my outputs are negative 1. So that means my solutions are x equals -2 and x equals 1. And I knew that there were only going to be two solutions because if you look at the graph, you have this upside down smiley face one and the lines going through it, so I can see that it intersects twice. And afterwards, they're kind of going away from each other, so I knew there wasn't going to be another solution. But you want to make sure you look through your table pretty well so that you don't miss any, because equations can have more than one solution. So that is it for this lesson. There's going to be a few for you to try on your own, just putting these into y1 and y2 and either using a table or finding the intersection on the graph, so that way you can practice both. If you have any questions or if you're having trouble with your calculator, make sure you send me an email.